Hey everyone, welcome back to the channel. I will directly get back to the point here. So imagine every time you want to have a cookie, you have to go to the bakery store to get it, right? But it sounds very tiring and exhausting, right? Instead of going to the bakery every time and have the cookie, what if you keep the box of cookie in your kitchen so that you can instantly grab it? It would be much faster and easier. That's exactly what caching does in software. Instead of fetching the same data again and again from the slow DB, we keep a quick copy of the data nearby so that apps can access it easily or instantly. Okay. So in this video, I'm going to talk about what is caching, what are the different caching strategies we have, how they work, and most importantly, how to choose the right one for your system. Okay, so I'm going to disappear from this screen now and we will directly get back into the video. So let's start with caching. What is caching, right? So a cache is a temporary storage area that stores the result of your frequently accessed data in memory, right? So that subsequent requests are served more quickly. So think of it like keeping your frequently used spices on the kitchen counter instead of walking to the pantry area every time you cook. It saves your time, right? If you have the data nearby or if you have the things nearby. Now here we have a simple, web server, web cache server setup, right? So suppose my web server has received a request from the client. So what it will do first, it will check whether the response, whatever I have received, whether I have that in our cache or not. So first it will, check in the cache. If it has the data, it will simply, give the result to back to the client from the cache. But if the cache does not have the response or the result, what the web server is looking for, so what it will do, it will query the DB. So it will query the database over here, and it will give back the result to the client. And what it will do at the same time, whatever data it has queried the DB, it will save the response or save that result to the cache also, so that next time if any request comes, what it will do, instead of querying the DB again, database again, it will simply give the response back to the client from the cache itself, right? So this is how normal, simple cache works here. So how cache helps you right here? So basically, uh, cache helps you to reduce the database workloads. Why I said database workloads, right? If you get the same query or same request from the client again and again, instead of querying the database, multiple times, you have already queried for the first time and you have saved the response here, right? What it will do, the next query, the subsequent query, or subsequent request comes from the client, so it will serve directly from the cache instead of directly querying the DB again. So basically it reduces the load on the database. It improves your query time, it improves your response time, right? You get the results very faster. So that's how it helps you. Okay, so let's move to the now common caching strategies. First one we have here is cache aside or lazy loading. So this is the most common caching approach, right? So here what happens, cache sits on the side, and application is the one which talks to both the cache and then the database. That means what happens, so when basically client request any data, so application is the one which first checks in the cache. If the data is in the cache, that means if there is a cache hit, it will serve the request to the client. If the data is not there in the cache, so what the application will do, application will you know query the database and get the data, and it will serve the client. And at the same time, it will save the data in the it will save the data in the cache as well. So if you see here,
application is the main entity which talks both to the cache and to the DB, right? There is no direct link between the cache and then the database. Okay, so there is no direct link between the cache and the DB here. Okay, so let's uh, understand it from analogy, right? So suppose you have a fridge, like and you want to, you open your fridge, and if you want to drink a milk, so you see there, if milk is there, you drink it. If not, what you will do, you will go to the store, buy it, and put it in the fridge, and then drink it. So you can think in this in a simple term, right? Like I have a fridge here. If I want to drink a milk, I will go to the fridge. I will open it and see if there is a milk. I will drink it. If there is not a milk, I will go to the market. I will get the milk, and I will put it in the fridge. I will put it in the fridge here, and then I will drink it. So that's how it's happening here. So you consider, uh, yourself as the application. So application checks first in the cache. If the data is there, that there is a cache hit, it read from the cache. If there is a cache miss, it queries the database and it sends the data, back to the client, and also it saves the data in the cache. Okay, now let's go to the move to the what are the use cases, pros and cons we have, right? So it's best for a read heavy workloads, like if you have a product catalog or if your user profiles, in that case, if we use cache aside or lazy loading, it's best for them. Like meme cache and Redis are widely used. It's resilient to cache failures. That means even if you're just a second, sir. So yeah, so it's resilient to the cache failures. That means even if your cache server goes down, that means your application can still get the data from the database by querying it. But it will become a problem in during peak timing, right? So when in during peak time, if your cache server goes down, so there would be a too many requests or too many loads on the database, and it might happen that database queries might get slowed down, and even your database might stop working. So yeah, that's one of the disadvantage. You can say that during peak time it goes down, your database might also stop working if there are too many requests on the database. Now, I think, yeah. So that's what, like, we have here in the cache aside or lazy loading. Now let's move to the next caching strategy, that is called read through cache, right? So here what happens, right? So here, if the client is requesting any data, what application will do, application will check first, in the cache. If there is a cache hit, it will give, like, return the data to the client. If the data is not there in the cache, so the cache will get the data from the database, not the application is not querying the DB and getting the data now. Okay, so here is the catch here. So you will ask me, right, like, what's the difference between the you know cache aside, lazy loading, and read through cache? So this is the main difference. In the previous scenario, your application was the one which were querying the database and getting the data if there is a cache miss, if the cache is not there in the cache server. But in read through cache, what's happening here, your cache is the one which queries the DB and getting the data, not the application. Okay, okay, so here let's understand. So while read through cache and cache are very similar, there are at least two key differences. In the first one, the application is responsible for fetching the data. Application is responsible for fetching the data from the database and populating the cache. But in case of read through cache, this logic is usually supported by the library or standalone cache provider. Okay, so this is the main difference. Like, if someone asks you, right, what is the difference between the uh, cache aside and read through cache. So this is the one of the main difference, where in cache aside your application is the primary entity which gets the data from the database in case of a cache miss. But in case of read through cache, if there is a cache miss, cache library or standalone cache provider is the one which will get the data from the database. Okay. Now, the second one is, unlike cache aside, the data model in the read through cache cannot be different than that of the database. It sounds technical, right? Here, this term, let's break it down. Okay. So, what it meant here, right? Unlike cache aside, the data model in the read through cache cannot be different than that of the database. Okay, let's understand this one from here. So, as I told previously, right, in case of cache aside, your application is the application is the primary entity which gets the data from the which gets the data from the database in case of a cache miss. So let's think of an example. So here, if I'm retrieving a user data or user profile, right? So I got so in my database, username is, first name is John, last name is Doe. So my application retrieve the data John Doe. This is the in a first name and last name format, and it has returned to the client. But as my application is retrieving the data, I can transform this data, I can receive this data before putting it in the cache, because your application is the one which is getting the data from my cache. From my querying application is the one which is querying my database, okay, and getting the data. So before putting into my cache, I can format the response, right? I can reshape the response. That's what so I can I can put the full name as a John Doe, instead of putting as a first name and then the last name directly into my cache server, right? But in case of read through cache, your application is not the one which is getting the data in case of a cache miss from the DB. Your here the library or a standalone cache provider which is getting the data from the database. That means your data schema, or the format of the data should be the same in the cache and then the database. It cannot be different. So in this case, both should be the same. So in case of if I talk about here, right, mm, so, yeah, uh, so uh, in case of, right, in case of read through cache, uh, your data should be the your data should be the same in the schema as the DB. Your data format should be the same as DB schema, right? Your data schema in cache should be the same as DB schema. So this is one of the I would say major things you have to keep in mind. So in case of read through cache, as our if I talk about our cache library or cache provider is the one which gets the data from the database. So here both the data should be in the same format. It cannot be different. But in cache aside, as application was the one, so here you can transform the data before putting in the cache. So your data format in the database and the data in the cache, it can be different format in case of cache aside, right? But in case of read through cache, it should be the same. So as I said here, it should be the same. Okay. So let's understand this from an analogy term. So in the previous case also we took the example of a refrigerator, and we said like we checked, right, we opened our refrigerator, and if the milk was there, we drink it. If not, we go to the store, buy it, and put it in the fridge and then drink it. So that was in the case of a cache aside. Now here in case of read through cache, right? In this case, suppose we have a smart refrigerator, right? So we are asking our smart refrigerator if there is a milk. Okay, we'll drink it. If it's empty, the fridge itself, order the milk and stocks it. So it's a kind of you just think of in such a way. uh, Maybe like so here I'm not the one, I'm not going to the store to get the milk. Here my fridge is only, as it's a smart fridge, so it will simply order it, and it will stock it, kind of. So yeah, maybe this analogy, you can think of, right? So here I'm the not who is doing it, or the application is not the one who is getting the data from the database. It's the cache itself, the fridge itself, who is getting the data from the database, right? Like in case of a cache miss. So now let's move to the next caching strategy, which we have here, that is read write through cache, right? So in write through cache, what happens? So whenever your application basically writes any data, it goes to the cache first, and then cache updates the DB. So suppose you're updating anything, or you are writing anything, right? Your application writes any data, that will be go first, getting to the cache. It will return to the cache first, and then it would be written to the database. That means if I talk about here, the write operations happens two times. Two times, we have here write operation. Okay, so here, as I said, right, when application wants to write a data or update a value, application writes the data directly to the cache, and then the cache updates the data in the main database. So when the write is complete, both the cache and the database have the same value, and the cache always remains consistent. Okay, so here you can think of this analogy, right? So you write your diary entry in your notebook. That would be your cache, right? So you wrote some entry in your notebook, and then your assistant, it will copy the data and it will put it in the official, I would say, archive somewhere. So here we are having, or we are writing two times, right? We are writing in the cache first and then the database. But one thing you can be of sure, right? Your data would remain consistent because you're writing two times. So the data in the cache and then the database would be always consistent. Let's understand use case pros and cons. So it has extra, as I talked about, right? It has extra write latency because it is written to the both cache first and then the main database. That is two write operations we are having. Right? And it is best for those scenarios where you need strong consistency, like in the banking transaction, right? In that case, this is this strategy is best, right, through cache. And cons, if I talk about, obviously it would be slow, right? It would be slower writes, because we are writing two times, so it would be slower. Let's move to the next caching strategy, that is write around, right? What it does. So here in this case, what happens, right? Data is written directly to the database, not the cache. So whenever your application writes any data, it will directly write to the database, and cache will get only, it will get the data when it's a read letter, right? That means it will it will get the data from the DB and stored in the cache. Uh, so it is, basically best use write around can it's basically it can be combined with read through cache and provides good performance in situations where data is written once and read less frequently. So you can think of, this would be best use where data is written a lot but rarely used, like in case of You can think of a real-time logs or chat room messages where you write a lot. It's rarely read. So in that case, this strategy is widely used, or it's used very frequently. First, the data is written directly to the database, not the cache. Just remember this point here. So here, first, directly app application is writing the data to your database, not the cache. Okay. So it has some cons, right? Usually because, so whatever you have recently written data, right, that may be slow to access, uh, because until unless your data is read, it won't stored in the cache, right? So let's move to the next caching strategy, that is, we have your uh, right back or right behind, correct? So in this case, what happens, right, your application writes the to the cache first, and then the cache asynchronously writes to the database later. That means, whenever any write is happening, your application will be first rightly writing to the cache. It won't update the database as of now, asynchronously. It will only write to the cache, and then your cache job is that, your cache job is basically that it will get write the data to the database. It's like, saving a draft first, and then you can fill it properly later, right? So it has the use cases pro, like if we talk about use cases pros and cons. So in the right back or right behind, right, it's best for right heavy systems like counters, likes, analytics. In that case, basically it's for right heavy workloads, it's best use, because you are directly writing to the cache first, and it's solving it, so it would be very fast, and then your cache is asynchronously writing the data to the database in a later scenario, right? The main disadvantage is that here, right, suppose your cache failure, if there is a cache failure, your data may be permanently lost, because cache is the one which writes to the DB or pushes to the DB in the background, right? But before pushing it or before syncing it, right, your cache server has gone down, right? If you have a cache failure, so your data may be permanently lost. Okay. So yeah, as I said, it would be super fast, right? It will reduce the DB load, and it would be good, during traffic spikes and all. So let's summarize very quickly here. So we have talked about different caching strategies, right? So we talked about first cache aside or lazy loading, right? Where the application is the one which gets the data from the which queries the database if in case of a cache miss, and stores the data in the cache, right? And then we talked about read through cache, where cache server or cache library is the one, cache provider is the one which gets the data from the database in case of a cache miss. So that was the one of the major difference in and in cache aside, your data format in the cache and then the database can be different, because your application is the one which stores in the cache, so it can change it before putting it over there. But in read through cache, both should be in the same format. Then we talked about write through cache, right? So here application writes the data directly to the cache, and basically cache updates the main database, right? So here in this case, what happens, you are doing the writes two times. First, it gets written to the cache, and then the cache writes to the DB. Two write operations it happens. Okay. And then we talked about write around. Here, data is directly written to the database, not the cache. And when the cache only gets the data, updated data, when the data is read again. And then we talked about write back or write behind. In this caching strategy, application writes to the cache first, and then cache asynchronously writes the data to the database in the later. So we talked about in total these strategies. But how will you, uh, how will you get to know, okay, how to choose the right one, which one would be the best for your system, which caching strategy? Okay, so let's discuss that one very quickly. So use cache aside, right? If your system is read heavy, uh, and occasional still data is fine for you, like in a product catalog, blog contents, then use obviously cache aside. Use write through cache if you need data consistency and you want fresh data all the time, right? Then you should obviously use write through. Example, banking and payment data. Also it would be little slow, right? Because here you are writing, your data is getting written two times in the cache and then the database. But yeah, you will have the consistent data, consistency between the cache and then the database would be, it would be good. Like it would be the, you will have always the updated data because your cache is the one which writes to the DB. Use write around if your system has lots of write, but not all the data is read frequently in case of a logging, chatbot, or chatting service or audit records, right? So in this case, you can use write around. And at last, we have write back. So use write back if your system needs super fast write and can tolerate a little delay in the syncing, like social media likes, counters, analytics. So in that case, you can use write back caching strategy. Okay. Okay. So that's all for this video. I hope you liked it. If you have any query, any suggestions, or anything to improve upon, please let me know in the comment box. I will definitely work on that. Thank you guys for watching this video till the end.